quick video, and I mean very quick. I'm going to talk about um, exponents, and here's the deal. Um, Exponents have different parts, and this is called the base. This is your exponent, and I believe some books say that this is your power, which I'm going to put a little question mark there. Basically, your base and your exponent are really what matters. So that was part one. Check. Done. Now, you might say, oh, well, that's nice that 3 to the 4th equals 81, but how did you get that? And I will show you right now. What you do is, if you have 3 to the 4th, the exponent tells you how many times to multiply your base by itself. So 3 times 3 times 3 times 3. And that's what it is. That's expanded out. And 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Check. Done. Now, we can also write exponents using variables. A times A times A times A times A. That is A to the 5th. And that makes sense because A is your base. 5 is your exponent. Now, what if we had something like this? What's A cubed times A squared? Well, A cubed would look like this. A times A times A. That is my A cubed. Times A squared. A times A. Well, now if we work backwards, we can say, well, what is this put all together? Well, I have 1, 2, 3, 4, 5. So it becomes A to the 5th. What I'm hoping you're noticing here is all I did was I could just add, if I have A cubed times A squared, I could just add my exponents and you get A to the 5th. The only thing that's necessary for this to happen is that your base for both terms must be the same. Check. Now you might say, well, what about division? And that's a great question because division's always a little bit funny. So check this out. You may or may not realize that when you're doing division, you can always do things as a fraction. So like 6 divided by 3 is really the same as 6 over 3. And what you may or may not know is that 6, oops, that's not true. 6 is really 2 times 3, and 3 is really 3 times 1, and look what you get. You end up with 2. So if I had A to the 5th divided by A squared, I could rewrite that as A to the 5th over A squared. And now I'm going to pull these apart. A times A times A times A times A over A times A. Well, remember, A goes into A once, A goes into A once, and now I'm left with the multiplication rule. 1, 2, 3, which is A cubed. Now you might say, whoa, 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 wait a second. What's 5 minus 2? A to the 5th divided by A squared equals A cubed. That's interesting because if I change this, not that, if I change this to 5 minus 2, I get A cubed. And so if you're thinking, wait a second, so all I have to do is subtract? That's right, when you're doing division, all you have to do is subtract. Which brings us to our next rule. What if I had A to the 4th divided by A to the 4th? Well, that's going to be A to the 0 because we just said it's really A to the 4 minus 4. And I don't know what just happened there. Uh-oh, I'm dropping my pen. I'm losing things. 4 minus 4, which equals A to the 0. But look what happens if I rewrite this as this. A to the 4 over A to the 4. A times A times A times A over. And what I'm hoping you're going to recognize is this. Wait a second. Those aren't 9s. Wait a second. Isn't anything divided by itself equal to 1? Yeah, because these are all turning into 1s. And we end up with 1. So what I'm trying to tell you here is this. A to the 0 equals 1. And there is one little note. A cannot equal 0, all right? So 0 to 0 does not equal 1. I don't know what 0 to 0 is. I'm not sure if it's even defined. All right, so anyway, I'm going to move on. Moving on, because I got to get this done. I have to go to bed. Super tired. So what if I had something like this? A cubed squared. Well, that really means I have a cubed times a cubed, right? Because whatever's in my parentheses is getting squared. And that really means a times a times a times a times a times a, which is a to the 6. Wait a second. I think what I'm hoping you're realizing is, I'll do one more. What if I had a squared to the 5th? I would have a squared times a squared times a squared times a squared times a squared, which is a times 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 a, right? So those two, those two, those two, those two, those two. And now when we add them all up, we'll get a to the 10th. And so what I'm hoping you're realizing is this. If you have a power to a power, you can simply multiply the exponents. And you get a to the 6. Now, there is one that's a little bit out of sorts, and it is what happens if you have a negative. Oy, oy, oy. Boy, this is exhausting. All right, what happens if we have a negative? Well, I'm going to go back to my division, all right? And I'm going to try to get rid of some of this. Oh my goodness me, I'm really struggling here. Really struggling. All right, so check this out. First thing I'm going to do is turn this to orange. All right, so what if I had a to the 3rd divided by a to the 5th? Well, once again, if I put it like this, I get a times a times a over a times a times a times a times a, right? A cubed, a to the 5th. And then once again, these start dividing to 1, and I'm left with 1 over a squared. But you might say, wait a second, isn't a cubed divided by a to the 5th? Didn't you say that we just subtract these? Well, you do, but look what happens. You end up with a negative exponent. But we just showed that this is equal. So a to the negative 2 is equal to 1 over a to the positive 2. And that's kind of it. There is one other way you can take a look at this. I'm going to take a quick look. Oh, no. I encourage you to take a look at something like this. I'm going to make a very quick chart. If I had 2 to the 0, to the 1st, 2 squared, and 2 cubed, say, well, that's 1, 2, 4, 8, and to the 4th equals 16. If I go 2 to the negative 1st, that becomes 1 over 2. 2 to the negative 2nd becomes 1 over 4. 2 to the negative 3rd becomes 1 over 8. What I'm really hoping you're going to notice is this. What's the pattern here? And what do you notice about their exponents? All right, so you might have a hard time putting it into words, but I encourage you to really struggle through and try to think about it. All right, that's it on exponents. Thank you.